Hello guys, good morning, good, so very informal. Okay, good morning, good afternoon to everyone here. So we are back at it again with short video hosting the sequel. It's made by Thanawat, you already know who we are. So let's go, let's get right into it. So a bit of an overview, we'll just talk about the deployment architecture and the service communication first through like the diagram like last time, and then we will explain about things HR probably wants to know, and then we will go on with the demo. Yeah.
Okay, so the first part, so this is the old architecture that we have. Essentially, we have the user connecting to the ingress, and then it will route to everything else. But this is like pretty much the same, except for the front end and back end doesn't have a line connecting it anymore.
Yay.
Okay. And then this is the initial design. This is what happens if we didn't use Django. So we could have been able to put the WebSocket as part of the backend, but because we used Django, that did not happen. This is what happened instead. So what we did is when the user sends a request, everything else, so this part is the same, but then we have an extra channel on Redis so that, let's say you need to send a notification, the backend will send a message to Redis, and then the Redis will publish or emit the message to the WebSocket, and then we run this in PubSub so that when one message comes from the backend, it will be emitted or published to every single WebSocket, and then the WebSocket is sent back to the user.
Okay, so for the tech stack, everything's the same for now, but then we also added two frameworks, dependencies, which are Node.js. This is used for making the WebSocket server itself. We also integrated Socket.io into both the front end and the WebSocket server so that we can use WebSocket. So this is probably the things you're looking for from us, right? Whenever the user logs in, they go to the front end, which is their computer. It sends the credentials, like usual, to the backend. But now, after the backend sends the JWT token, it also sends the user ID alongside as well. So that then we made the front end subscribe to this particular channel event, so that whenever the user wants to receive a notification, they can get it directly from the WebSocket server through this thing. This will be the identifier on like which notification should go to whom. Yes. And for when the user one, let's say user one likes user two's video, what happens will be first, front end will make a local change. So this conforms to the read your write pattern. And then it will then send the API call to the backend, and everything is basically the same. Where an object or an entity will be created on the backend and sends to the database. Yes, and for the comments, it's pretty much the same. We also make like local change first, and then we send the comment API to the backend. It stores everything, and then whenever we wanted to update the comment, we will just send like a message to Redis, and then the Redis should be sending these comments to the receivers. The backend will be the one who identifies who needs to receive the video. So maybe you have to see the comments as well because you have commented on the same video before. So the backend will be the one who decides who to get it. It goes through the Redis, and WebSocket will be the one to distribute the packets and the comments to every single one in the front end. Mm-hmm. So when we view the video, what basically happens is that The front end will get the video from the back end like usual. This is P2 stuff. I will just not explain much. Whenever the video starts, the component loads, it will subscribe the user to a certain event channel so that it receives a comment real time. And whenever the video ends or before it exits, it automatically unsubscribe for the user so that when the next video comes up, it will start again, as in subscribes to the next video's Socket.io channel.
Okay, so the next one is for view likes and comments. So essentially so this is more like for updating. So the way we do it is the front end has a set interval thing in its feed page, and also the video viewing component. And then every 10 seconds, it will send a GET request to the backend. And then on the backend, we set a cache on Django so that it will store the response to the feed in Redis cache. We set this to every 5 seconds. And if this thing is outdated, then it just gets it in the database. And then the last one is the notification system. So essentially what happens is, let's say user 1 likes user 2's video. So it will send a like or comment API request to the backend. And then the backend will create that and then store it in the database. It will also send a message to Redis. And then Redis will publish that message to all of its subscribed or to all of the users that match the identifier that Pat mentioned before. And then on the client side, it will basically just show up on the bell thing. And then we thought that it might be a good idea to tell the user that there's a new notification with sound, so we added some sound effect for the bell as well.
Yes. Okay. Now on to
the demo.
Yes. Hooray.
Okay.
Whoa.
So let's start with the views. So as you can see, this one so right now has 68 views. If we go in here, and then we finish watching it. So the way we implement it is that it increments your view after you finish watching it. And then if you go to the other one, you can see that it went up to 69 after a while. So
nice.
Yep, that's for views, and then the like counter works the same way. So if you press like, it will show up on the other side, something like this.
Yes.
Yes.
So the sound you heard like just a second ago comes from that browser that receives the notification.
So it shows up here. And then for the comment, so let's say that we're watching this video at the same time, and then we send a comment, hello, Pat. And then it will show up here. And then this one, you can also do the same thing. Hi, Nawat. It's some front-end issue. I'm too lazy to fix it, so. Yeah. And then this is it. I forgot. So we have like, update, comment, and notification. So I think that should be it.
Yes, right.
Back to slide, I saw something like 10 seconds.
10 seconds.
This one?
You wait 10 seconds, what does it mean?
So in the front end, there's a piece
interval.
of code where, so when you create, let's say the feed page or the video pop-up, it has a set interval on create. So like so we use view. So on create, it will have like an interval thing where you can put a function inside of it. Mm-hmm. So that's what wait 10 seconds means.
Yeah, so basically every 10 seconds it makes an API call. So basically like YouTube, where you don't subscribe like through WebSocket, but you ping the backend every 10 or 5 or
So this is
so on
to check
second.
whether you are still alive.
This is just to get the updated
Yeah,
view,
so
like
update the
the
numbers.
counts.
But I thought it's real time.
It's not real time.
This one is not real time because like in the handout we read it can be timely, so we wanted to try that out.
So let's
as
say
well.
let's say I watch this video to the end, and then this thing is still, it's not updated yet.
Yeah,
And then it
it just
will
got
go up.
updated. It's like not so real time.
Yeah, the reason that it went up is probably because of timing.
Yes. So it's not real time for the view counts.
For that part,
For
Yes.
view counts and like counts, it's not real time, but for comments and notification, it is real time.
But then Ajahn, so you remember us talking about the read your write pattern? For likes and comments, it's also like read your write. As in, whenever you like the video, it locally adds one to here. Yeah, so that's how we implemented it.
okay. Can we put up a slide?
One slide.
Can we start from this very first? Okay. Second, third, okay, fourth, okay, fifth. Okay. So that WebSocket server is the Node.js. So basically, it's another service, right?
Yes.
So it decides which channel to send the message to, right?
Well, technically no, because the user has their own like ID, right? And the front end knows it, as in like the client knows it that okay, I am, let's say, user number 1 and 2, and then backend decides who to send the notifications to. So basically, for example, the user 1 and user 2 comments on the video, like any video. So when another user comments on this video, it should be, notification should be sent to both of them, as well as the comment, as in case they are still on the page. That means the backend will be looking through the database, whether or not, okay, now user 1, do you need the notification? User 2, do you also need the notification?
But how
Yes.
do you know whether the user is online?
So basically, the WebSocket server sends to a channel with that user ID. So basically,
If the user, if that channel doesn't exist, then it's not.
something along that line. So the notification will not reach the user that is like not connected to the channel.
If that user connect later, what will happen?
They will directly fetch from database. So from what Nawat presented, the notification page, we also made entity for notification so that for later, we can fetch the notification and send it to the user whenever they log back in. There's this field called is seen, so that it keeps track of which notification has been seen or not seen yet.
So if I understand correctly, the backend
Yes.
basically try to look for the relationship
Yes.
between the videos and the comments and everything.
Correct. Yes.
See who need to get the message, right?
Yes.
And then you basically put all of that into Redis.
Mm-hmm.
And then the WebSocket server is the one relay that message to the user.
Correct. Yes. So let's say there's this one notification that applies to 100 people. Let's say it will still be counted as one message to the Redis. There will be like one field called the receivers, which is a list of integer that says, oh, number 1, number 2, number 3 should be getting the notification. And the WebSocket will just send it to all of these user ID channel.
Okay. Seem like a lot of traffic, a lot of internal traffic is going on, even if the user is not actually online, right?
Correct. Yes. Mm-hmm.
That could be one downside because imagine you have like
Millions. Yes.
then unnecessary message is created
Correct.
internally.
Yes. So one fix would be just to have a mapping of who's online and who's not online around here, since it connects directly to the WebSocket server, right? So I guess.
I thought that the backend was just sending like a message, and then the WebSocket server, which is Node.js, decide whether the user is connected or not. If the user connected, then it will start to send.
Right.
This one, you said just send everything.
Yes.
The backend decide and create. So I guess it's create as many channels as you needed inside Redis, right?
Yes. No, but in Redis there's only two channels, one for receiving notification packets and two for comment packets.
But it's create one or two for each user.
No. That's this part is separated. So Redis connects to WebSocket and it does its things. There's only two of them. But like for here, I think it's also two, but for each user, so it's like separate.
So like the way we implemented it is that the message queue that comes from the backend into Redis, there's only two of them. One for the notification and one for comment. And then this one is also two. But when the WebSocket emits to the user, then each user has its own channel.
Yes. Yeah. Yep. Each user has its own channel, but one video there's like one channel for active video, right? So it is true that from WebSocket server, since if there's like a couple of replicas, all of them will emit the same thing. But then I think since we're just making it so that it works for now, we didn't have like a mapping of who's online, who's not online. Yes. Just yet. I think we can implement it later.
I see. So because you're replicating the WebSocket server,
Yes.
then that means the message that go into Redis will go to only one of them, right?
It would go to all of them.
Imagine backend and WebSocket server doing pub/sub stuff together.
So let's say you have 5 users that needs to be notified. How doesn't that mean it's going to send the message 5 times? Because outside not 5 times. So let's say you have 2 replicas. So does it mean that all 5 messages going to be sent
Yes.
twice?
Yes, correct. That is still the missing part of the whole architecture, so that you have to actually look at who's online and who's connected to which server, which we didn't implement for now, but it will basically do what you said. Correct.
So one easy way would be fetch some of the message onto one of the servers, and then the other one fetch. They don't fetch the same thing. So they don't subscribe. Well, I don't know. It depends on how you set it up. So they don't get the same message.
I see.
You could do some sort of partitioning, but that's the way it should work.
I see. Okay. Sounds great. Okay.
Good.